order to solve problems involving rotary motion, it is often necessary to find arc length. So in this presentation, we're going to be dealing with the applications of angle measures. Of course, which is prior to our previous topic, wherein we have convert angle measures into radian measures and so on and so forth. Okay, so let us consider this circle with a radius r. Okay, and in this circle, we have down here a certain angle measure, the theta here, which represents the angle measure. Okay, and in order for us to look for the length of this the length of the arc subtended by the central angle, or the arc intercepted by the central angle theta, what we're going to do is just to derive it from the formula of the circumference of the circle. Have the formula in finding the area of the circle as 2 pi r. Okay, wherein we have already discussed that the circumference of the circle, wherein we assume that the value of the radius is 1, then we have here 2 pi, okay? But we are just after the value of s here, or the measure of the arc length, okay? So what we're going to do is just for us to what? It's just for us to multiply, or for us to get this one, since theta here is just a part of the circle. Okay, so meaning we are to multiply the theta measure here, or the angle measure here, by its radius, and that would be the formula in getting the arc length of a certain circle. Okay, again, the formula in getting the arc length, which is represented by small letter s, that would be the radius multiplied by the angle measure. Okay, so let us have an example. Alright, so let's say we are to find for the length of an arc of a circle with a radius of 10 meters that subtends a central angle of 30 degrees. Okay, balik po tayo dito sa formula. Okay, make sure that your angle measure would be expressed in radian measure. Okay, para mas madali po nating makuha yung arc length. Okay, so now, first things first is for us to illustrate our problem. Okay, sabi dyan, we have a circle with a radius of 10 meters, wherein the radius that subtends a central angle of 30 degrees. So the theta measure here would be 30 degrees, and we are looking for the arc length, okay, which is intercepted by the central angle. So what we're going to do is just for us to have our formula. That would be s equals theta. That would be theta. Okay, that would be theta. Wait a minute. Alright, that would be theta multiplied by the radius. Okay? Alright, there we go. Ito pala ang theta. Okay, so again, that would be theta multiplied by the radius of the circle. And that would be equivalent to, by just substituting the values. Okay, again, we have to express our theta measure, or angle measure, in radian measure. So what we're going to do is just to have it 30 degrees equals, so for us to convert this, what we're going to do is to multiply 30 degrees by what? By pi over 180 degrees. Again, we just have to multiply it with pi over 180 degrees. And that would be what? That would be 30 degrees times pi over 180 degrees. That would be equivalent to, okay, so for it to be more accurate, that would be 30 degrees multiplied by pi over 180 degrees. That would be pi over 6, okay? That would be, again, that would be equivalent to pi over 6, or 1 over 6 pi. Okay. 1 over 6 pi, or pi over 6. Okay? So this will be the equivalent, or the equivalent value of 30 degrees in radian measure, and that would be pi over 6, or in terms of pi. But you can actually have it you can actually have the exact value as 0.5235 and so on and so forth. Okay, but then again, you can actually what, you can actually express the answer, or express the measure of the angle in radian measures in terms of pi. So we have down here the value of our theta, or the value of, or the angle measure, as pi over 6. And what we're going to do is just to what, to plug in the values to our formula, which is S equals pi multiplied by the radius, and that would be, S would be equivalent to pi over 6. That would be pi over 6 multiplied by the radius, which is, the radius is 10 meters. Okay, and that would be equivalent to, that is pi over 6 multiplied by 10. Alright, so that would be, the value of S would be, or the arc length would be 5 over 3 pi, or 5 pi over 3. That would be 5 pi over 3. Or, approximately, the value of the arc length, approximately, that would be equivalent to 5.24 meters. Again, that would be 5.24 meters, rounded off to the nearest hundreds. Okay, so we have just what, we have just solved for the measure of the arc length. Okay, next, let us have another example. It says here that a central angle theta in a circle of radius 4 meters is subtended by an arc of length 6 meters. So we are to find for the measure of theta in radians. So how are we going to do this? Let us first illustrate it. We are given a circle with a radius of 4 meters, and we are and the measure of the arc length, that which is subtended by the central angle theta, measures 6 meters. So what we are looking for is for the measure of the angle here. Okay? Or the measure of the angle. So what we're going to do is, of course, for us to still use the formula in getting what? The formula in getting our arc length. But we will manipulate this one for us to get the value of the theta, or the angle measure. Since the angle measure po yung hinahanap natin, we can actually manipulate this one algebraically by dividing both sides by r, wherein the resulting equation would be theta is equal to what? Is equal to the arc length over the radius of the circle. And that would be the formula in getting our angle measure. Okay, so that would be theta equals the measure of the arc length, which is 6 meters. That would be 6 meters over 4 meters. Be 6 meters over 4 meters. And if we are to convert this one, we have down there theta equals, what is 6 over 4? Or 6 divided by 4. 6 divided by 4 is equivalent to 1.5. Meaning to say, the value of the theta here would be equivalent to 1.5 radians. Okay? So that's gonna be it. Since the problem requires us to find the measure of the theta in radians, that would be 1.5 radians. But if we want to express our answers and degrees, minutes, and seconds form, or in the DMS form, we can actually convert this into DMS. By what? By simply what? By simply multiplying 1.5 radians by, okay? By simply multiplying 1.5 radians by 180 degrees over, that is 180 degrees over pi. Okay? And that would be, that is 180 degrees over pi. that would be 85 degrees. That would be 85 degrees, 56 minutes, and 37.21 seconds. So that's how you convert it, just like what we have learned from our previous discussion. Yet, since the problem requires us to express our answers in radians, so meaning to say the angle measure would be 1.5 radians. Okay, so since we are dealing with circles already here, we can actually find, of course, the area of the circle. Yet, in a given angle measure. So we are talking about what we so-called sector here. So ano po si sector? Sector is actually a part of a circle. Let's say, for example, we have here a circle with a radius r, and a given angle theta, wherein this central angle subtends this arc or intercept this arc, meaning to say the colored part of the circle here is the what we so called sector. Okay, a sector is a portion of a circle in a given angle. Okay, so how are we going to find for the area of a certain sector? Okay, so let us derive. Since we all know that the area of a circle is equivalent to pi r square. Okay, we all know that the area of a circle is pi r square, but since we are just dealing with, a part of a circle, meaning to say theta here is just a part of 2 pi, meaning to say the angle measure theta is a part or a fraction of uh the whole circle, which is equivalent to 2 pi, meaning to say this area of the circle, if we multiply it with the fraction that deals with the angle measure, that would be theta over 2 pi since this represents the part or the sector part of the circle, then we may multiply it with the area of the whole circle. So for us to get the area of a certain sector, so by simply multiplying or by simply multiplying this one, we can actually remove pi here because pi over pi is 1, and then we multiply both sides, or we multiply r squared by theta over 2, and that will yields to what? That would be r square theta over 2. Okay, so this would be the formula in getting the area of a sector, or if we rewrite this one, that is actually equivalent to 1/2 of the square of the radius multiplied by the angle measure. Okay, again, remember that angle measure should be what? Should be expressed in radian measures. Okay, so let us have an example. Says here that we are to find for us the area of a sector of a circle with a central angle 60 degrees if the radius of the circle is 3 centimeters. Okay, so let us illustrate that. We have here a circle with a radius of 3 centimeters, and then we are given an angle measure of 60 degrees. So we are to look for the area of the shaded region. Okay, so for us to do that, we have, of course, first things first is for us to convert angle measure, which is 60 degrees, into radians. By simply what? By simply multiplying 60 degrees with pi over 180 degrees. Okay? So these are just applications of what we have learned from our previous discussions. So that is 60 degrees multiplied by pi divided by 180 degrees. That is simply what? So using our calculator, that is 60 multiplied by pi over 180 degrees. That is pi over 1/3 pi, or pi over 3. Again, just like what I have said a while ago, we can actually express Radian measures either through exact value or in terms of pi. So in terms of pi, we have pi over 3. You have to remember this because we're going to be dealing this with our discussions on the trigonometric functions of any angle. Okay, because we'll be dealing with unit circles there. All right. So if you want to express that in exact value, that would be 1.0417 and so on and so forth. But then again, it would be much easier if you're gonna express our angle measure in regions in terms of pi. So meaning to say, 60 degrees here would be equivalent to pi over 3. Then after that, after having that, we will now what? We will now uh, plug in the values to our formula, and that would be the area of the sector, which is represented by A, is equal to 1/2 of, again, 1/2 of the square of R. That will be 1/2 of the square of R multiplied by the theta measure in radians. Okay, so by plugging in the values to our formula, that would be 1/2 multiplied by the square of 3, all right, or 3 square multiplied by the angle measure, which is equivalent to pi over 3. So let us just copy this one. Okay, and by again simplifying what is to be simplified, that's going to be 1/2 multiplied by the square of 3 is 9. We all know that, multiplied by pi over 3. And then since we are given the calculator, or we are allowed to use our calculator, that's going to be 1/2 multiplied by 9 multiplied by pi over 3. Oops, sorry. Again, that is 1/2. That is 1/2 multiplied by 9 multiplied by pi over 3. All right, so that's gonna be equal to, or the area of the sector is equivalent to 3/2 pi, or 3 pi over 2. Again, that is 3 pi over 2. So this will be the area of the sector, but then again, you can actually express this in exact value by just pressing this one on your calculator, and that will yield to what? The area of the sector will be equivalent to 4.71. That is 4.71, or rounded off to the nearest hundred, that is 4.71 what? Okay, the unit of measurement we have used here is centimeters. So meaning to say the area of the sector is 4.71 square centimeters. Remember that you are dealing with areas here. That is why the unit of measurement must be squared. So meaning to say that is, or the area of the sector, given that the radius is 3 centimeters and an angle measure of 60 degrees, is equivalent to 4.71 square centimeters.